Hello, everyone. Welcome to the artificial intelligence session of the computing track of SBGames. In this session, we are going to have 5 paper presentations. For each paper, first we're gonna watch a 7 minutes long presentation, followed by 3 minutes for questions. The audience can ask questions through the Wava application, okay? And I really ask you to ask the questions there during the presentations because there is a small delay during the broadcast on YouTube. So ask the questions during the presentation. So during the question moment, I'm going to be asking the questions to the authors. Okay. And you can also ask questions in the commentary sections of YouTube. Okay. So let's begin with the first paper called the Development of an Autonomous Agent Based on Reinforcement Learning for a Digital Fighting Game.
Hello, this is the presentation for the work Development of an Autonomous Agent Based on Reinforcement Learning for a Digital Fighting Game. The authors are me, João Bezerra, Luiz Goes, and Alisson da Silva. This presentation will follow the following steps. First, the introduction, then objective, related works, theoretical framework, methodology, results, conclusion, future work, and then references. A problem with commercial game agents is their fixed behavior. Their strategies are pre-programmed scripts in which the developer needs to think about every kind of situation possible in the game environment. Playing against an agent is very different from playing against a human opponent. Competitive players acquire bad game habits when training against the machine, and the machine itself has predictable reactions, which means more repetitive gameplay. So the objective of this work was to develop an autonomous agent based on reinforcement learning for a digital fighting game. Our goal is that it adapts to the way players play the game. So it iterates over players' input, which is constantly changing, to offer new tactics and new challenges for the player to overcome and improve their skills. In the related work, in the work of Pato, the authors develop an abstraction of the game Counter-Strike with agents using Q-learning. In the work of Wang and Tan, the Falcon architecture is used in the implementation of agents in the game Unreal Tournament. The agents are able to adapt to a new opponent or an unknown map in a short period of time. And in the research by Da Silva and Goes, Falcon Network is used to implement an agent capable of playing the game Hearthstone. The agent achieves an average of 80% win rate in matches against agents using Monte Carlo research. So other works have been using Q-learning in the Falcon architecture and had great success while using them. So Q-learning, it's a reinforcement learning technique. It uses a Q table which lists transitions between states. So AREN are the adaptive resonance associative maps. They are adaptive neural networks. They are useful if the environment that interacts with the agent is not known or partially known. And Falcon networks are the fusion architecture for learning, cognition, and navigation. They use a three-channel cognitive neural network architecture. If a combination of variables in the 3 channels is sufficiently different from the known and expected ones, a new neuron is created. This is a picture of a small game developed by the authors, Fighters Arena. Matches are for 2 to 4 players in a 3-dimensional arenas with top-down view. The objective is to attack the opponent until their health bar depleted, which causes the elimination of said opponent from the competition. Now for the agent implementation. First, I'm going to talk about the environment. Here are the 11 game environment variables analyzed by the network, like the action the opponent is currently performing, if the agent's special bar is full, if the opponent's special bar is full, etc. For the actions, 11 basic actions were defined, representing different strategies executed by the agent. So first there are jab, tilt, strong, and strong tilt, which are basic physical attacks with varying speed and strength. Keep distance, in which the agent tries to move away from the opponent using defensive moves. Punish, in which the agent quickly approaches with an attack. Roll, in which the agent dodges incoming attacks. Retreat, in which the agent goes away from the opponent. Grab, where the agent comes closer to the player and tries a grab. Shield, which is defending, and charge, which is an invincible attack, but with a huge punish window at the end if the agent misses this attack. And here is the reward function. So if the agent has hit the opponent, it will be between 0.8 and 1, greater for greater damage dealt. If the opponent has attacked and didn't hit the agent, or the agent defends an attack by the opponent, it will be 0.6. If the agent was hit by the opponent, it will be 0.1. We didn't use 0 reward because no action is completely dependent of the agent. And for any other situation, the reward is 0.5, which is a neutral value. The tests were focused on the performance of the network and its learning process. So the matches were against a single opponent. Both agents use the same character that has no polarizing characteristics in their design. The selected arena is a closed rectangular room with no obstacles or external elements to avoid interference that could change the results at random. The progression used for the action selection policy in the agent's training was, in the first match, we used epsilon as 1, so all actions were executed at random, and for the later matches, epsilon was decreased linearly until it reaches 0, and when it reaches 0, it uses only the acquired knowledge. In the tests carried out, the second half of the matches used epsilon equals 0. And for the results, the win rate by the agent was 89%. The average remaining agent life was 37%, so it beat the opponent and still had 37% life remaining. The standard deviation went from 0.2 to 0.19, which means it became more consistent in winning. So the conclusion was that the proposed objective for this work was achieved because it was possible to implement the autonomous agent using neural networks in a fighting game. The agent was able to learn and develop game strategies with autonomy. It was able to adapt to the way the opponent plays, and it have satisfactory performance in terms of the winning rate. Regarding the network used, the complexity was sufficient for efficient learning, and at the same time, it did not impact the performance when performed in real time. For future work, we'd say to use complementary networks for each state of the main network, so the agent can optimize the actions performed in each state. And this can contribute to the results. For example, with the optimization of sequences of attacks is executed by the agent when it selects an offensive action. And here are the references used in this presentation. Thank you.
Okay, great. Thank you, João. A great presentation and a very interesting work. So let's see. We have one question here from Luis Fernando. He wants to know, how does your method perform in comparison to other fighting games?
In terms of like said in the paper, usually the fighting game agents have fixed strategies. So if this agent, this develop agent, was put to fight versus a fixed behavior agent, it would eventually adapt to how it played and would eventually start winning more than losing.
Okay. And continue the same question that Luis Fernando asked. How long would take for the agent to overcome the opposite AI? Like how long it would take for imagine that we are trying to run your AI in another fighting game. How long would the AI need in order to overcome the fixed AI?
I think it's kind of dependent on the complexity of the game environment in terms of how many variables and how many different situations are there. So I think it's relative to this.
Everything depends on the actual complexity of the overall AI of the game. And probably also in the complexity of the game, because some fighting games are quite easy, others have more complex movements, so that also can influence the AI on how it's learning, probably. I also have a question. You applied your approach only for a fighting game, right? Can it be applied to other game genres? What would need to change in order to apply the same approach in another type of game?
I think the way we implemented this agent is can be easily ported to other kind of games because it's like a mix of fixed and dynamic agent logic because it has some predetermined actions or strategies, for example, approaching or running away from the opponent. This could be implemented as in other contexts, and yeah, I think the same implementation can be done to other kind of games.
Okay. Let's see if we have more questions. Let me check YouTube here. No, I don't think we have more questions. So thank you, João. That's a great work. Let's continue working with this. Let's continue work later. I see that you have some future work, so keep working. It's a very interesting work there. Okay. So let's move to the next paper presentation, which is team recommendation for the Pokemon Go game using optimization approach.
Pokemon Go is a mobile game. In this game, the Pokemon characters are scarred around the real world, and the players should looking for the virtual monsters. In this game, in addition to catching Pokemon, the trainers can enter battles against the computer or against other players. Choose a good team for the battle is a hard task, due to the wide search space involved the various combinations of teams present in the game. Focus on PvP battles, the goal is to find a team that can fight the opposite team. This paper proposed a heuristic approach to recommend teams for battles in the Pokemon Go game. In this sense, we investigate some optimization techniques, looking for the best way to recommend a team. The algorithms we use for the experiments are iterate local search, genetic algorithm, and memetic algorithm. This table presents the parameters values used for each algorithm. The number of individuals and iterations were set at several tests in order to find the best configuration for these parameters. Each individual is represented by a team of 3 Pokémon. This value was chosen because it is the amount of Pokémon used in a PvP battle. Fitness consists of the 3 functions that simulate battles between all team Pokémon. Return the value of fitness. Each Pokémon battles with everyone on the other team. Size in the battle, the odds is unknown. For the crossover, a cutoff point is chosen at random. and the genes between two parents are exchanged. The mutation occurs with the replacement of a team Pokémon by another one in the database it handled. The flowchart describes all experiments. The heuristic receives a database with a chosen randomly generated teams as input, which we want to combat. The algorithms execute 5 times each team, generate a total of 5,000 executions, and generate its average, which was used for the purpose of comparing the techniques. The MA is more efficient to fitness and ILS to time. Due to their natures, the GA proved to be intermediate with results not far from the MA and with time very close to the ILS, which for all problems proved to the most appropriate approach. In the first image, we can see the big time difference of the MA in relation to the other techniques. In the second image, we see that GA has a great or less scope than ILS. In the meantime, the difference is minimal and GA also obtained the best case of time. Regarding performance, the MA obtained the best results. This is due to the additional stage of local search, but still with average values close to GA. The table represents the p-value of the Shepard-Wilk normality test, first two columns, and the results of the post-hoc Friedman test, last two columns. Based on the results of this table, we can assume that the distribution delivered by optimization techniques do not follow a normal distribution. We can see that both comparisons are statistically significant for our analysis 2x2 analysis and both evaluation metrics. Our work analyzes optimization techniques for recommending things in the Pokémon Go game. We strongly recommend the use of GA size. It is fast than the MA and obtain better performance values in relation to the ILS. In the future, we intend to investigate other optimization techniques in addition to the other forms of crossover and also to change the type of local search in the MA.
Okay, great. Thank you. Thank you. I think we have here R2 to answer some questions. Let's see. We don't have any questions from the audience. Let's check YouTube. No. Okay, so actually I have a question. So did you compare the results of your algorithm, of your genetic algorithm, with the results that could be produced by a brute force algorithm or by a random forest algorithm? I think your microphone is off. Okay.
Oh, it's on, okay?
Yeah.
Can you hear?
Yeah, I can hear.
So we don't check and compare our approach, and we just focus in optimization techniques. So the first one that we can think about, and when we say about optimization, we think in a genetic algorithm. It's simple, and we need to see the results about comparing the genetical with. It's not to just to compare, but we compare it with a local search. After this, we compare with. Let's try to use another heuristic approach to compare with the genetic with this one. So we have a genetic and we have a local search. We can combine them and produce a mimetic. But we think about it. Let's try the random forest.
Yeah.
Oh, not have enough time.
Okay, great. Yeah, I think that's important. You need to analyze, like, every time you're applying a genetic algorithm to solve a problem like this, you need to analyze the space search, the space state, like how complex is the space of search. And in this problem, you need to go deep there to really see how complex a random algorithm or a brute force or a local search algorithm could be, finding a solution there. So, but yeah, I think a comparison like this would be very interesting to do, just to make sure that your genetic algorithm, it's really useful in this case. It's better and can really overcome a normal brute force algorithm, which usually takes more time to find a solution in a very complex place. Like I imagine, in this case, could be a complex one. Okay, but thank you. It's definitely an interesting work. Let me just check if we have more questions. Okay, actually, we have one question here from YouTube. So, in the conclusion, the meta is correct, or there is a surprise on the team composition? It's a question from Pamela on YouTube.
Can you repeat it? I don't get it out the question.
In the conclusion, the meta is correct, or is there a surprise on the team composition? I think what she wants to know is that you, at the end, you recognize a team that surprised you, like it was something that you were not expecting.
Sometimes is we have a previous knowledge about the Pokemon Go game. We three of the authors play this game dearly. So when we check, when I hey, you agree with this team that can battle with other the proposed team in game and win easier. And when we analyze every comparison, sometimes get the algorithm propose a team that we never think about.
Yeah, I think that's the great advantage of using genetic algorithms for a problem like this. We find solutions that not even us were expecting.
Yes,
Okay.
yes.
Yeah. All right. So thank you, Arthur. Thank you, and continue your work. It's a very interesting work. Let's move on. Let's move on to the next paper, which is, let's see. Okay, investigating case learning techniques for agents to play the card game of Truco.
I'm going to present a paper called Investigating Case Learning Techniques for Agents to Play the Card Game of Truco. My name is Luiz Álvaro. This work was developed in collaboration with Juan Moral, Gustavo Paulus, and Joaquim Assunção from University Federal of Santa Maria. This paper is being recorded and it will be presented in the SBGames 2020. As described in our paper, Truco is a popular card game in many regions of South America. But to create artificial intelligence models for a card game like Truco is a challenging task for many reasons. For example, there is a very limited availability of Truco data. And moreover, as a card game, there are stochastic and imperfect information characteristics that had to be considered. In our project, Truco bots were implemented with case-based reasoning techniques. It means that hands of Truco were recorded as cases in case basis. And those recorded cases were used by the Truco bot implementations. In this paper, in particular, we investigate case retention approaches to the collection of Truco cases and the storing of those Truco cases in case bases. The first approach that we explored was the retention of new cases. And this approach was explored by bot 1. We call this the bot 1. In doing so, bot 1 executes a query for the current game situation. If at least 10 cases were not retrieved from the case base from each case base with a similarity of 90% or more, the learning criteria indicates that bot 1 has to learn. In doing so, bot 1 plays the game action that is suggested by the majority of the retrieved cases and stores this new case in its case base. Bot 2 does similar things, but uses a different retention strategy. Bot 2 retains new cases with substitution. It means that if the learning criteria is true, bot 2 plays the action that is suggested by the majority of cases retrieved and stores this new case in its case base. Bot 2 also plays and remove the retrieved cases that had a lower score than the current one, and also store the new case in its case base. The strategies used by bot 3 and bot 4 are based on random game actions and retention of new or best cases. It means that when the learning criteria is true, bot 3 plays a random game action and then stores this new case in its case base. And bot 4 also plays a random game action, removing the retrieved cases that had a lower outcome, a lower number of points won in the game than the current one, and store this current case in its case base. The last bot that we implemented was bot 5. Bot 5 used a tutoring strategy based on the active learning technique. It means that when the learning criteria is true, bot 5 plays an expert suggestion and stores this new case in its case base. To test the developed bots and the strategies of case retention, we initially collected 513 hands of truco. Those hands of truco were recorded in a case base called baseline and used by the bot 0. Then bot 1 to bot 5 played 300 truco matches against bot 0. And during these matches, cases were added in the case bases of bot 1 to bot 5. After that, we tested the performance of the agents using the case bases that were recorded for each one of them. In doing these tests, we played 30 duplicated truco matches when the agents used the same set of cards in those matches. The results against bot 0 were the following. Bot 1, that used the retention of new cases, had the best results. Bot 2, that used the case substitution strategy, was the only one that lost against the bot 0, the baseline bot, because it forgot some of its cases, and this process was not effective. Bot 5, based on the active learning technique, had a much larger case base than the other bots, even though bot 5 has not achieved a large number of victories against bot 0. But which one is the best truco player? According to our experiments, bot 3, the bot that memorized new cases and made random game moves whenever necessary, achieved the best results. Bot 3, in fact, overcome all other agents with a reasonable margin of victories. In summary, this work investigated alternative case learning strategies The resulting agents were able to play better than compared to the agents that were initially collected with human players. And the strategy that showed the most promising results was the one that played random game moves and retained new cases. Thank you.
Okay, great presentation. Very interesting work. Actually, I never saw any other AI to play Truco before. Actually, probably there are. Let me start with this question. Are there other methods, AI methods, to play Truco games?
Well, we are developing some different agents to play Truco, but all of them are being developed in the same research group in our university. So we are trying case-based reasoning. We are doing something different as well with Professor Joaquin. Yesterday, if you want to see, there was a presentation from Lana in the short paper sessions, and there's an interesting presentation. I recommend you people to see. But I didn't know, for the best of my knowledge, any other techniques to play Truco.
Yeah, that's true. I never saw any other paper on this subject. Maybe because it's only in Brazil. I'm not sure if Truco is played in more places, not only in Brazil, but I don't know. Maybe it's a very interesting topic because
in fact, we are in contact with author of a book, Truco book from Argentina. So he told one of my students, Gustavo, probably Gustavo is listening to this presentation, that he wants to participate, to collaborate with us to develop even more the agents that we are implementing.
Oh, that's great. Let me just check if there are questions. No question here, no question on YouTube. Okay, but I have one more question. Why do you think bot 3 was the best one?
The idea of storing making random game actions, it's a good idea. In fact, it allows the agents to learn something new, something that goes beyond what people recorded in the case basis. And it seems to be a good idea.
Yeah, all right. So great, thank you. And let's move on to the next paper, drafting in collectible card games via reinforcement learning.
Hi, my name is Ronaldo, and I'm here to present my work, which I developed alongside Anderson and Luis, called Drafting in Collectible Card Games via Reinforcement Learning. So, let's begin by talking about collectible card games, or CCGs, which are two-player strategy games played with a custom set of cards. And what we refer to as playing actually involves two related tasks. The first is building a deck from the set of available cards, and second is using that deck to battle other players. And with the usually large and intricate set of rules, learning to play CCG ends up being a difficult task, both for human players and artificial intelligences. And partially due to this difficulty, the recent advances in game playing AI have not yet reached CCGs. With that said, in our paper, we investigate whether deep reinforcement learning approaches can yield competitive deck building AI, considering the current literature, specifically in the arena mode of collectible card games. In arena mode, decks are built in a process called drafting, in which for n turns, the players pick one of k random cards presented by the game and adds it to their deck. On the right, there's the deck building process in the arena mode of Hearthstone, where k is equal to 3 and n is equal to 30. To the best of our knowledge, there's only one published work so far on the topic. And we use deep reinforcement learning, which is a framework to tackle sequential decision problems, such as drafting in arena, by refining a decision-making strategy. We call it a policy, via trial and error, using, in this case, a deep neural network to represent the policy. So deep reinforcement learning, or DRL, describes an interaction loop where the decision-making agent makes actions in the environment, which returns a new state of the environment and also a reward signal that serves as feedback on the agent's action so far. And our proposed approaches follows this scheme. At each draft turn, we extract features from the cards in the game and feed them as input to the deep neural network that is trained with DRL, which outputs a policy from which we act in the game, choosing a card. And we propose three different approaches. The first one is called history, because it uses a history-aware state representation. That is, we pass as input to the network not only the K cards to choose from on the present turn, but all cards chosen in the previous turns as well, so that it can consider those in its reasoning. The second one is called immediate, and it uses a history oblivious state representation, which only contains the K cards to choose from and no history. And the third, LSTM, is somewhere in between the two. It uses the history oblivious state representation as well, but has a layer of long short-term memory units. So it's also called LSTM units, which are capable of remembering the past turn, and therefore it considers the cards chosen in the previous turns. Our agents are rewarded proportionally to the win rate of the decks they build when used by a battle AI. We instantiate our methodology in Legends of Code and Magic, or LOCM. That is a CCG designed specifically for AI research that also features arena-like deck building. K and N are also 3 and 30, and we re-implement the game engine as OpenAI Gene environments. From LOCM cards, we extract all features that are relevant to the card's quality and convert them to a numeric vector. And then we train our networks using the Proximal Policy Optimization Algorithm, PPO, and repeat all training using two different battling AIs, Max Attack and Greedy. Our training sessions consist of 30,000 episodes, having 12 equally spaced checkpoints, in which we save the network and evaluate using 1,000 episodes. In our first experiment, we compared our approaches among themselves. To do that, we performed 10 training sections with each approach, using the best hyperparameter we found to compile average learning curves, which are shown in these graphs. We observed that with both battle agents, the simplest approach, immediate, had better results in terms of win rate throughout training, followed by LSTM and by history. We also compared our approaches to others in the literature. More specifically, we selected 2 baseline agents, as well as 3 that we consider being the state-of-the-art in arena drafting. The results were that, while playing first and second have significant differences, and that our approaches outperform all others with both battlers. In our last experiment, we re-executed the strategy card game AI competition held at the COG conference in 2019, replacing the draft portion of one of the baselines, Max Attack, with our best draft agent. The result was that Max Attack was originally in the 10th place, and it ends up in the 4th place solely by building better decks, even with its very simple battling strategy. Summing up, our trained draft agents outperform all selected agents in the settings we experimented, and we expect that more training episodes would be needed for LSTM and history to achieve better performance than immediate. Another aspect is that our agents are fast and do not require powerful hardware or even a labeled dataset to train. We conclude this work in which we present a game-agnostic deep reinforcement learning methodology to build decks in the arena mode of collectible card games, and we interpret our results as positive evidence that deep reinforcement learning can achieve competitive performance in the task. Lastly, we consider this work a step towards superhuman game-playing AIs for CGs. The source code for the game engine, the G environments, the experiments, and the final draft agents are available at GitHub under this URL. And thank you very much. I hope you liked it, and please refer to the paper for more details.
Okay, great. Very interesting work. Congratulations, Ronaldo. So let me see if there are questions. Oh, no questions. The audience is really shy today. So let me ask you one question. Did you try different feature sets as the input for the neural network, or you extracted all the features that were available at the cards?
No, we just extracted all features that were relevant to the quad's quality and let the network sort it out.
Okay, so you didn't test different sets. You just selected all
No.
and let the network. Okay, all right. And about future works, are you planning to continue this work, develop future works?
Yes. The next steps would be first to try more episodes in training, and then to try in a different card game like Hearthstone. And we are also starting to work on a better lean AI as well, using deep reinforcement learning. Those are not our next steps.
Okay, great. It would be difficult to adapt this to another card game because you use the features and all the information for this AI game that was created for research, right? How complex it would be to adapt the approach that you developed to another card game that has different features, different cards?
Uh-huh. Yeah, we try to make the methodology game agnostic, so that the fewest change, so that we would need the fewest change to to use another card games. So things like the feature extraction and the battling AIs, those things are specific and should be changed. But I think it's fairly easy.
Okay, great. Oh, we got one question here from Bruno Feijão. He is asking for you to talk more about LSTM. It seems great, but you got no good results with the LSTM. Can you talk more about that?
Yeah, we actually expected that LSTM would be the best approach, but well, we have some hypotheses. The strongest one is that we need more training episodes, or maybe the game we chose was too simple to interaction between cards to be strong enough. And well, we're gonna try more.
Yeah, maybe you need more data, you need a more complex game because everything can be affecting the results. It should provide better results, but actually got bad. But
Yeah.
okay, more tests are necessary to really check if it can really produce good results there. Okay, so great, thank you, great
Thank
work. Let's move on to the final work. Yeah, it's the final one. So, a cultural model for non-player character behaviors in role-playing games.
Hello everyone, my name is Luis Fernando Bicario, and today I'm going to present to you the paper, A Culture Model for Non-Player Characters' Behaviors in Role-Playing Games. So, first of all, we have to notice that the game market is growing year by year. And even though this seems really optimistic, we have to be fair with the game developers. They are in a really competitive market and they have to use tools to make their games more special. So how can we do that? What kind of tools we can use to avoid the player to go to another game, to go to a more interesting game? So one of these strategies is to use procedural content generation, like it was done in Minecraft, but this strategy is focused on map building, world building, and we wanted in our project to focus on the interaction between the NPC and the player and not the way the world was built. And how can we do that? How can we make the NPC more human? How can we make the behavior of this NPC seem more reliable to the player? So, a paper in 2017 has already done it. He used emotion and personality models to define how these NPCs would behave when the player was acting towards them. So the models that they used were the Plutchik's wheel of emotion, which we will be using too. The personality model chosen was the ocean model, which is defined by 5 traits, each one varying from 0 to 1. And what if we could simulate the cultural behavior of an NPC? What kind of culture model we could use to do that? So we decided to use the cultural dimension theory of Geert Hofstede that is defined by 6 dimensions, but we wanted to sum it up, and we decided to use the social metrics of the Bolognese approach in 2019 that would define, based on Geert Hofstede, the 6 main social metrics as wealth, rationality, politeness, individualism, time, and dignity. However, the Bolognese model was missing one dimension, that was uncertainty avoidance. So we decided to add to our adapted model the trust level and the prejudice level that combined would substitute the uncertainty avoid that was missing in Bologna's work. We also decided to add Proxemics concept to our model, in which not just the actions of the player would trigger some reaction of the NPC, but also the social distancing of this player towards our NPC. So if the player just approaches our character, he may run away because he doesn't feel comfortable with that distancing. And talking about our model itself, the player acts towards or approaches the NPC, resulting in an emotion as the NPC is defined by personality and cultural dimensions, which combined will result in an emotion, and this emotion will be filtered as a mental state, and this mental state will finally result in a behavior towards the player. So, summing it all up, we will have player action and proxemics related to cultural dimension. This cultural dimension plus the rationality, which will determine the intensity of the emotion, results in the event emotion. The event emotion allied with the personality will result in the mental state, and the mental state in the end finally will influence the behavior, and mental state allied with the prejudice level will influence our trust level. As an example, we can see here that when our player approaches this NPC, his trust level is growing. The player will approach this NPC and he will start trusting him just by approaching. And this will be his reaction. Here, we will see that this NPC is going to approach our player, and he's not going to like the player near him. So he's going to shoot our player. In the end, the contributions of our project are applying the Geert Hofstede model to a role-playing game, which was never done before, combine culture, personality, proxemics, and emotions in one single model, and different from Bafa's work, we used all the 48 emotions and the personalities instead of fixed or random. For future work, we could, instead of having just one region with random instances of NPCs, we could have different regions, each region with an environment which, combined with the culture, would generate traditions, things that the NPCs would do frequently based on the environment and culture, like the way they would wear the clothes, the way the buildings would be made, the food they would eat, and other habits. We could also change the way we map the culture and emotions using fuzzy logic instead of deterministic ranges. Use different culture, personality, and emotion models to test if combining these other models could make it work, and make further tests with users to see if this this model is effective in comparison with a simple state machine. And also migrate the game to 3D environment, which would benefit to see the NPC reacting emotionally to players' behavior. So if you have any question, you can ask me right now, or contact me with email, or contact my advisor, Bruno Feijó. Thank you.
Okay, great. Very interesting work, Luis. That's definitely a very interesting work. So let's see if we have questions. No questions yet.
The audience is still shy, right?
Yeah, they are. But I don't know. I'm gonna ask the question here. So,
okay.
did you? I'm not sure. Did you test your approach placing NPCs from different cultures in the same place, or they were all from the same culture?
Yeah, exactly. I chose I built just one region, and I placed randomly through the map these NPCs with different values for culture and personality. That was what I did.
That was the actual experiment.
Yeah,
all right,
exactly.
All right. Okay, we got one question here. Let's see.
Oh.
So, Jeber is congratulating you. He said it's a very interesting work. As you use chain of different variables, personality traits, emotion, context, to influence actions and trust, how do you calibrate all of this? And how do you validate this calibration?
I'm thinking, what did he mean by calibrating?
I think because you probably have some variables there that control the effects, right? That control how your agents are behaving based on their culture, right? So how do you calibrate those variables? Maybe those rules that define how those different cultures and personality, like you have the input there, right? So probably you have some rules that define how each input will be affecting the output.
Oh, okay. As I said near the end of the presentation, we mapped the cultural dimension plus the rationality with a formula to determine what emotion would result from this combination. So, as I said, in the end, the rationality would influence the intensity of the emotion. So, like in the range of the sadness emotion, if the emotion chosen was like grief, it means that the rationality is low, because the rationality at if the rationality level is low, it means that this NPC will be more influenced by his emotions than he wouldn't without this with the rationality. And we do these steps with predetermined values for each emotion. Each emotion has is based on the Bloch scale of emotions, so it has 4 axes, each axis with a value from -1 to 1. So it's like a table of all these values with the mapped emotions. So to calibrate it, we would maybe, as I said in the end, use instead of doing the approach, the deterministic approach, we would use fuzzy logic maybe to make this less deterministic, as I said, right?
Yeah. Okay, all right. We have one more question here from Steban. He's asking, do you think that including cultural model might bring special challenges for game designers?
Yes, I think so. It depends on the way you would model the culture to influence in the actions of these NPCs, or if imagine that you don't want the cultural traits to influence on the emotion. You want them to influence on other aspects of your game. Yeah, you can do that, but you have to think on that carefully, because like I said, I chose the rationality, specifically the rationality dimension, to do something that I thought that made more sense with the with how the game was built. So if you think that some dimensions would be more important than others, you could use that. You could map your game like that, and you could, as I said in the end, make this culture influence the way these NPCs would be wearing the clothes or eating some food in a more in a place like Rio de Janeiro, which we never have winter. We would wear less clothes or more open clothes, and we would eat more, not more cold food, but food not that hot, as we are not in a cold environment. So also it would also influence the way the environment would react. Like it would rain a lot. It would people would turn on the air conditioning. So there is a lot of things we can do based on culture. So there's a lot of aspects that can influence in the way you build your game based on culture, right?
Yeah, not necessarily challenges, but I would say that this model can bring new possibilities for game designers.
Yeah.
They can develop many things in the game using the output from the cultural model to adapt the way the NPCs interact. Maybe even adapt the story, because we can use that the way the characters are interacting and create like an interactive story that depends on how the model is changing the behavior of characters. So yeah, that's a great
maybe place one character inside the story that has a different culture from another character, and this would change the way the story would be built from one point to the end. So it would be really good. There are a lot of ways we could use this model.
Yeah, there are many applications now. Now it's time to explore the possible applications. Okay, so we are almost out of time. So thank you, Luis. That's what a great presentation and a great answer and questioning session. So thank you.
Thank you.
All right, so thank you for all the audience that was following this session. Now you can go to the Discord server if you want to talk more with the authors or to discuss a bit more about the overall content of SBGames. And after this session, after the break, we have another computing. The computer track has another session there, so you can go there. There are more papers. So thank you for watching.